I'm like, what are those? What do those symbols mean?
Yeah.
I've never seen those before.
That's the only problem, right? If you know what the symbols meant, it wouldn't really be that bad.
That's pretty much all you have to learn, though, right?
It's
Switch from algebra to calculus is just learning.
Well, I mean,
symbols and what they mean.
There's a lot of concepts behind
The symbols.
the stuff that we do with the thing. Yeah, there's what a symbol means, and there's how it was put together, and what's the idea behind it. What calculus does, and you're like, God damn. We talk about slopes of straight lines, right? Calculus talks about slopes of things that curve.
Oh, okay.
So the slope of something that curves is always changing, so it itself is a function.
Changing.
So I can, anyway, that's enough for calculus. So let's see. With what we just did, we actually are through 11.3 almost. We got one little thing out of 11.3 to talk about. We'll be done with 11.3. It's crazy. 11.3 starts with the idea of the b squared minus 4ac that we just did. Only looking at that. And the official name we give this piece is the discriminant. Discriminant. The b squared minus 4ac.
I've heard that before.
Why do we give it that name? Because it discriminates between real answers and complex answers. Right. One of the few last places where discrimination is fun. Discrimination is not bad until it's used in a certain way. Then it's bad. Discriminate between when you should run away and when you don't have to run away. You want to be able to do that. But you don't want to discriminate against people. Then you have to take a whole afternoon off and learn not to do that.
Learn how to be a better person.
That's some magic right there. Now here's the other thing. Help me out here real quick. Solve this by factoring. Just dredge that up. It's going to happen every now and again to us. That's the first thing you try when you see a problem like this. Even if I don't say by factoring, you check to see if factoring works, because that's the easiest way to do it. It should be. How do you factor this? X minus 6? X plus 3, so you get what you answered. Alright, so you're all waiting for the twist or the trick or whatever. No trick, there it is. That's how you do it. Now, what if I started with the answer and said, what equation did this come from? I think we sorted in one like this yesterday, I can't remember. But what if I told you the answers to, something of this form are -4 and 3. Can you create the equation that those came from? And hopefully you understand it's just, so if I gave you those answers, well, where did the 6 come from? X minus 6. Where did the -3 come from? X plus, all right, so where would -4 come from? X plus 4, where would 3 come from? Equals 0. And then you just multiply this out to put it in the form, this quadratic form, 4x minus 3x is x. So that is the equation that would have those, the quadratic equation that would have those answers. You see that? Not a big deal. It's just
Working backwards.
Yeah, working backwards. What about this one? What if these answers were 2/5 and -1?
Plus what?
So let's start, where would that -1 have come from? All right, now where would the 2/5 have come from?
Minus 2.
Now, to be honest, we don't see shit like this, right? See how that's 0? Now, just to show you the technical stuff behind this. Couldn't I multiply both sides by 5 if I really felt like it? Hell, I can multiply both sides by 11.28 if I really wanted to. It wouldn't do shit for me, so I'm not going to do that. But why would I multiply by 5? Because then it becomes 5x minus 2. That's where fractional answers come from, if you remember. When you factored and it said each equal to 0, when would you get a fractional answer? When that was not just 1. Because you have to add 2 divided by 5. That's where 2/5 would have come from. 2/5. And then you can multiply this shit out. You have 5x squared plus 5x minus 2x, or plus 3x minus 2 equals 0. That would be where it would have come from.
And you need to use 5 to multiply it because of the denominators?
Yeah, yeah. And now watch. You don't do that every time now. You're better than that. You incorporate what we just did. X equals 3 would have come from what?
X minus 3.
So if it's over like 7, you just put a 7 there. Because that would be, I would have to divide by whatever's in front of the x. I'd have to divide by it. So if it was just 3, it would be x minus 3. But it's 3 over 7, I better put a 7 there. So when I set it equal to 0, I would add 3, divide by 7. What if it was x equals negative 5/3? Where would that have come from?
X plus 3, or 3x plus 5x plus 3.
So if it was that, it would have come from x plus 5.
Oh, 3x.
But you have to have that on the bottom, so that's got to be there. 3x plus 5. That's where that would have come from. Yes, sir.
I guess say relationship. Like relationship, like for example, the 3 over 7. The 7 just moves to the left, and then the 3 just comes down and just negates.
Sure, whatever way you want to come up with.
Wouldn't that be 3x minus 5 because it's negative?
No, but remember, why is it negative? How would you do this? You would subtract 5. Oh, there you go. And then I would divide by 3. So whatever's in front of the x is what you would eventually divide by, which is why the bottom goes in front of the x. And we already know that change the sign. So since that's positive, that was minus. Since that's negative, that's a plus. Sweet. So those are the two things in section 11.3, are the discriminant, the b squared minus 4ac thing, and creating equations with given solutions.
So that discriminant is this part right here?
Yes, cool.
Okay.
Okay.
Yeah, okay.
So of course, we talked about quadratic equations, all these different ways of solving them. So you should have expected this. The next section is, of course, the word problem section.
Oh, right.
That leads to quadratic equations that we now have a bunch of ways to solve. So a lot of these word problems are going to be word problems we've dealt with before. It's just that before, we had to make sure that it came out to something you could factor, because we didn't know quadratic formula yet. We didn't know any of this shit yet. So it had to be something we could factor. That's the only thing we knew. So now it's the same word problems we've seen. There's work word problems, there's distance, rate, time word problems, and you're like, oh, thank God, I thought they were in my past. They are still with you. It's just that when you set up the equation, it's going to be quadratic. And then you can use quadratic formula, you could use square, you can use whatever the shit makes sense. You could factor it even if it's factorable. So for example, here's a problem. It says here that a well and a spring are filling a swimming pool. That is really weird. So somehow they got a well, they got something coming from the well, and they got something coming from a spring, and they're filling this swimming pool with who knows what kind of water. That's all they... water. Water. What type of water is in that pool? Together they could fill the pool in 4 hours. So there's a spring and there's a well. And then that's together. Aww. So together they could do one pool in 4 hours. The well, working alone, can fill the pool in 6 hours less time than the spring. So the well takes 6 less hours than the spring does. So which one's going to be just X? Which one do you have to know first? The well is 6 hours less than the spring. I have to know the spring first. So it's going to be X, and now the well is 6 hours less than that.
X minus 6.
There it is. 6 hours less is X minus 6. Yeah.
It's like, come on.
So that's a work problem. We've seen those before. How do I do this now? This is what I love about you guys. Some of you guys are like, excuse me? That's a previous section, sir.
Dare you.
I don't give a shit. Anything we've learned can happen to you. Yeah, make them all have the same denominator in my mind. So what does this guy need? He needs a 4 and an X minus 6. 11. So you multiply it by 4 and X minus 6. 4, X minus 6. What does he need?
X minus.
He's got an X minus 6.
Yeah.
He needs a 4X. What does he need? He needs a lot of help. He needs
X minus 6.
an X and an X minus. He needs everything. He needs an X minus 6. All right. Right? We've done this before. If I make all the bottoms the same, I can multiply by that thing and they all die. So technically I could just do this shit now. Boom, you're dead. When's the only time I could kill fractions?
When it's an equation.
Yes, when there's two sides to it. An equation or there's a fractions inside of a big fraction. Yeah, so here I can multiply both sides by 4x times x minus 6, and that's why they all cancel. So what do I end up with? I get
4x minus 24.
Equals x squared minus 6x.
beautiful. Keep going. Finish that. Finish it. Oh, cool. So before you go racing to do quadratic, can you factor this? Yes. X
Minus 1.
minus 12. X minus 2. So x is either 12 or x is 2. Now here's different. Now on the surface of it, it seems like both of those are okay because neither one makes any bottom 0. But there is a major problem with one of those answers. What does that x represent?
Spring.
What about the spring?
How fast it can fill.
How fast? There's time. You with me? Now, you could pretend like time could be negative, but time can't be negative. You could say it's 4 hours until we leave, so it's -4, t minus 4 hours. But it's not really negative time. Holy shit, what the hell would negative time be? Do you see how the 2 would cause the time for the well to be negative? Meaning 4 hours before it started, it would be done. That would be neat. That would be great. I'm about to start my homework. Oh, it's done. That would be different. Too bad it's not possible. So x is 12, which means the spring does it. I can't remember the units now. Oh, where's my book? Oh. What was it? Hours. Spring would take 12 hours. And how long would the well take? 6 hours. 12 minus 6, 6 hours. So together they can do it in 4 hours. It makes sense because both of these are bigger than 4. They have to, yes.
How did you know when to put 1 over x at the very beginning of the problem?
That was the work problem. We've seen those before. The spring can do 1 pool in this many hours.
Okay.
This guy could do 1 pool in this many hours. And together they could do 1 pool in 4 hours. That's how the thing starts off.
Okay.
I like it. I like it. Now here's the other part of this section. Does anyone know what that formula is?
Nope.
I think they tell you. Yeah. This is Newton's law of gravity. If you have a mass, one mass and another mass, the force of gravitational attraction between them follows this formula, where r is the distance between the two. So the closer two bodies get, the bigger the attraction is between them. And g is just a constant that makes things work. Right? So when you were born, there was a greater gravitational attraction between the nurse and you than between you and Jupiter. Right? Because Jupiter's damn far away. And the nurse was right there. Hello, baby. It's not like you're going to get off of me, baby. But it's not that big. If you're surrounded by mountains, if you're out hiking, there's mountains on both sides of you, you weigh a little less. Because the gravitational pull of the mountains is counteracting the gravitational pull of the Earth a little bit. You weigh like 0.0000006 pounds less. Yay. Look at me, yo. Yeah. No, not quite like that. So you try to do this. I want you to solve this for R. Solve it. Do it.
Oh, jeez.
I don't know. I'm asking you to do it. Good luck.
Okay, so, all right, so you said solve for R, correct?
Yep.
So we do reciprocal of G.
Oh my God, no. I mean, what's the first bad thing about solving for R? Why did I pick R? Oh shit! Because what's bad about it? It is what's in the denominator. That sucks. All right, we'll make that not true anymore. It's an equation. I could do all kinds of shit to an equation. How do you make the R squared not in the bottom anymore? Multiply both sides. Okay, keep going. That's a beautiful thing about an equation. So many times you go, I hate this part of the equation. Oh, let me kill that part then. Yay. As long as you do it to both sides and everything, and it's legal. So in math, it is legal to kill things.
So how do you solve for R?
My math teacher said I can kill people. No. Only if it's legal.
Okay. All right.
Oh.
Get my shade.
Let's see.
Is that right? You gonna show us how to do that?
What's up?
You gonna show us how to do that?
No, I'm joking. Of course I am. Good Lord. Yeah, did you guys get done with that? Fantastic. Moving on.
It's up to you to actually do that.
So the very first thing, like I said, is to multiply by r squared. Really?
Yes.
What is that? They do exactly. They say do this. Did you get
And on
done?
to the next.
Okay.
Yes, pretty much.
And they don't even tell you if you're right or not. And
They're
it's
like,
not a
did you get
quiz.
this answer? No? Okay, well, we're not.
Ask me after class is the best answer I've
Oh,
heard.
well, for me in grad school, it sucked to see this. Exercise left for the student. In class, you'd be like, well, then you do this. Well, it's exercise left for the student. You guys just do it on your own. Tell me if you have questions. Moving on. It's like, holy shit. So the r squares go away. Let's focus.
You square root it, yeah.
Oh.
I don't square root yet, because
That's it.
we'd have to get rid of first.
F.
F.
Divide.
Divide by F. And the last thing you do is
Square root.
square root. Now, let me ask you this. I've got you so programmed to put what there?
You square root the F too?
Plus minus.
You have to square root everything, yeah. Plus or minus. Why would plus or minus not make sense here? This is a physical thing. R represents the distance between two things. Can't be negative. That'd be weird. It'd be inside me or something. Blech. So that's it. That's what the distance. If I knew the force of gravitational attraction, but I didn't know how far apart they were, I can now figure it out.
So you can plus or minus depending on what it's asking you on the work.
We know this is true. Mathematically, a lot of numbers could be the answer to some equation. This is a physical world problem. It relates to the distance, so it can't be negative. So we know this. If I said, how long do I build this, make the side so the shed is this much area, and you get, it could be 3 feet or -7 feet. You're going to throw that -7 out. Although the numbers work. Math goes, what's wrong with that? We go, I can't make it -7 feet long, math.
It wouldn't have anything to do with like the absolute value. I thought it was just the distance that is traveling instead of like negative value.
Well, I mean, absolute value is related to the idea of distance because a distance has to be positive. Here, there's no absolute value. It's just I picked the one that makes the sense. The answer's got to be positive. So I picked the positive root, not the negative root.
Gotcha.
Yes. That's all. We already know I got to throw answers out when it's a physical problem sometimes. Right? What two numbers multiply to be 8?
4 and -4.
Try this again. Give me two numbers that multiply to be 8.
2 and 4.
2 and 4. What about -2 and -4? Don't they also multiply to be 8? Yes. What if it's the area of a shed has to be 8 square meters or something? Right? So both, so 4, it could be 4 by 2 or it could be -4 by -2. What's that mean? -4 by -2. You know, it's like, what is that? Right? Is it too long ago now? It's the upside down? No. Shed in the upside down? No. Yes, okay. We don't want that shit. We don't want Demogorgon, shed, no. You're not getting my reference, that's all right. You're just not fully living life. Okay. So of course there's going to be other ones with just pure letters in them you got to solve, and it's going to involve taking square roots or killing square roots.
So we would see a problem like that in the homework, solve for r at
Yeah,
equals-
totally. I just took
Okay.
that one out of the homework.
Okay.
Out of the homework section anyway. What about this guy?
I'm looking forward to it.
Solve for, what do they say? Ooh, yeah, it's the one I want. Solve for G. This is the period of a pendulum that is L long. So have you ever been to the Natural History Museum in Balboa Park? Is that the one with the big pendulum in the front? Yeah. You ever been there and the pendulum you come and it knocks the little wooden dude over? Knock! Certain times of the day, it just shows the rotation of the earth and all kinds of stuff. Notice how the period meaning how long it takes for it to swing that way and then they come back. That doesn't depend on the mass at all. It doesn't depend on how massive the pendulum is. It only depends on how long the pendulum is. That's really neat. Possibly just to Jeff, but that's all right. So here you just got to solve for G. You don't have to know any of the shit I just said.
Okay, good.
Just got to solve for G. I do love that the formulas they give you are real formulas used in the real world
What's that?
to do real shit. So of course there's two problems with the G, right? Can somebody tell me what the two problems are with it? It's under a root and it's under. It's in the denominator, right? So what can I do to start moving in the direction? What's kind of like in the wrong place? See how this guy's in the wrong place? If I divide by him, I can then square and kill the square root, right? Now you could square right now. I don't know if some of you guys did that. Just got to remember to square this guy too. If you divide both sides by 2 pi, right? Little known wrapper 2 pi. Now what can you do? You can take care of one of the problems, right? One of the problems is G is under a square root. Can't I kill the square root now? Yes. If I just do what to both sides?
Oh, you squared.
So you get T squared over 4 pi squared equals L over G. I don't know if you guys noticed this, but you could cross multiply if you wanted to. It's a fraction equals a fraction. Well, I gotta wait and see if you notice it first. So we get T squared G equals 4 pi squared L. So then G equals 4 pi squared L over T squared. Shit. What? What happened? That's so weird.
Process for a second.
Oh, little. Why? So G times T squared, 4 pi squared times L.
Okay.
Why is the G not by itself? Divide by the T squared. All right, cross multiply right here. Bam, bam, bam.
Okay.
And then divide by the shit you don't want. So G in this case is the gravitational acceleration. 32 feet per second per second. So if you drop something every second, it's going 32 feet per second faster.
So how would you say that answer in real life terms?
The gravitational acceleration can be found by multiplying the length of a pendulum times this constant and dividing by the square of its period. So if you have a pendulum, you know how long it is, and then you pull it back and you let it swing, and you time how long it takes for it to do this. You throw all that shit in there, you can figure out an estimate for the gravitational acceleration, how quickly something moves faster and faster toward the earth if you drop it. So unfortunately, if we jump out of a building, what happens to us? We accelerate towards the ground, right? And then acceleration is this G. That's the gravitational acceleration. That's a great letter to use for gravitational acceleration. That's awesome. On other planets, that value is different.
Do we use something like that in physics?
All day, man. This is physics. Yummy, yummy. Yes?
So pretty much a lot of things in life deal with.
Sorry, I almost said fuck yeah. Yes. Oh, I did say fuck. Oh, I did it twice. Yeah. Yes. Which is so sad for people in the math community that look out there and see how it's being devalued and devalued. At least in America. It's almost like we want to have a downfall of America. The best way to do that in the country is to devalue math. Right? Or that's a great way to control a populace, is to not let them understand math, so you can do all kinds of shit to them.
Yeah, exactly.
Oppression.
But we're not going to talk about the politics of
So anybody else want-
demonizing mathematics. Okay. I just want to do one more section. Do you have your... Move all mine away.
Just one more section?
Read it too. Want to do 2 more sections?
Yeah.
No? All right, thank you.
I'm already behind in homework.
Sounds like we already have 4 sections to do with homework.
Well, you have a lot more than that. Eventually you do. All right, so last section for today.
Thank God.
I am working towards letting us out early.
Yeah,
Will you
please
stay here even if you let us out early?
give us power.
Maybe. Why?
Just asking.
Oh, yeah, I will. You got some questions for homework stuff, or?
Yeah.
Okay. Let me see. Yeah.
That's a lot of homework to do with watch forward. Tell you what.
All right, so if I want to solve this,
Quadratic Formula.
true, how do I start to write the answer? What would I write right here, Ryan?
X.
X equals, I like it, right? Right? I'm making a big deal out of that for some reason. X equals negative b plus or minus square root of b squared minus 4ac all over 2. I just throw numbers in. All right, so that's not the point of all this, obviously. This is old news. Okay. So here's the point of this. So how would I solve, let's see if I can get you guys with me here. Oh, let's do this. All right.
Nice. No, it's already done. Good. Oh, no? No.
So why did I say x equals this? Because that's that. That's, how would I, if I could factor this, how would I start to factor it? I do x, blah, blah, right? Okay. So here, if I start to factor this, it would be what?
4.
X. If I started trying to factor this.
Squared.
X squared. Okay. So here, I'm going to use quadratic formula because this is in the right form. This is quadratic in form. What the shit does that mean? Do you see how that is double the power on this?
Yes.
We've talked about this before, actually, when we were factoring. As long as that's true, it's quadratic in form. And the last dude has got to be constant. So sure enough, that is double that. It's quadratic in form. So I can say x squared equals all the shit we already did, so I just get to here. Do you guys understand what I'm saying? This quadratic formula wouldn't change. It would still be negative b plus or minus the square root of b squared, blah, 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 blah. Yeah, I can respect it.
It's the same thing. What? Just take the square off? Because it's okay. Yeah.
That doesn't change. But what that equals changes. Yes?
Is coming from the 3x squared or the x to the 4th?
Yes.
What?
Which one?
Yes, both.
Oh, okay.
Yeah. Because if that was a third power, I couldn't do shit.
Okay.
But because that is half of this,
Do you
That's
leave
like
that
half-
x squared on the
we're
left
not,
side?
well, let's see. So if I simplify the side, I get where I got before, right?
Mhm.
Oh.
And of course, am I done yet? Do I know what x is?
No.
No. So how do I figure out what x is?
Square root.
So we get x equals plus or minus square root, negative 3 plus or minus square root of 5 over 2.
How does it look at that?
Now watch, now watch. Can anybody tell me how many answers this is? No. 4.
4.
There's a positive with 2 options, and there's a negative with 2 options. So that's 4. Why does it make sense there's 4 answers?
Because this
Power
was
is 4.
It's a
Right?
fourth
Oh, yeah.
degree. Fundamental theorem of algebra. Right?
So if it's a 6, then it's 6 answers?
Yes.
I have a question for you. So what
Sure.
if you had x to the third plus x to the second?
Then you couldn't do it this way.
Okay. So
Now, to be really honest, you're not going to see that here, but if you saw that, what could you try? Synthetic division. Well, we're not going to, though.
What was your question?
What if this wasn't half of this? What if it was a cubed and a square?
Oh, I see.
You see, then I could try synthetic to help me out.
Yeah,
Or
because
yes.
you would add a 0x.
Add a 0, take some guesses for what it would be, and try it out until I got something that worked. I mean, that synthetic division is actually a way to factor something.
So you say you can solve all equations with anything, basically. I don't know. I just I think it makes sense, but it doesn't. It's so hard
If-
to like know what to do.
if that-
I don't know what you want
If
from
that
me.
power, if that power is half of this one,
Okay,
I can do what I just did.
okay.
If it ain't, I can't. That's all I said. Right? That's all I said.
Yeah, but then we got
And then you
lost about
said, well,
different
what could you do? And I'm like, oh, well, you know, you can't do this shit, but you could try synthetic division. There's other things you could try. You just can't do this. Because what is this? This is the quadratic formula. What's the only thing it works for? Things that are quadratic in form. That's why it's called the freaking quadratic formula. So as long as this is twice the power of this, then you can do it this way.
Is that basically saying it's a perfect square?
No. Mm-mm.
No? Okay.
All right, let me show you. Let me see if you guys like this way better. There's something called U substitution. Sounds like invasion of the body snatchers, but
Sounds like use.
yeah. Let me just show you the idea and see what you guys think. If I let U be x squared, so I'm substituting x squared with U. Why is that okay? Because what's x squared? Tell me. What's x squared? I don't frickin' know. Well, let me call it U, because I don't know what that is either. So what I'm doing is I'm capturing the form of this. So if U is x squared, what's U squared?
X to the
X4?
X to the fourth. There you go. If U is x squared, then when I square U, I would square x squared and get x to the fourth. So how can I rewrite this? What's x to the fourth?
squared.
U squared, right?
Oh, okay, okay.
What's x to the fourth? U squared.
Okay.
What's x squared?
Stop, get down, man.
U.
U.
Okay.
Doesn't that look normal now? So see how that's the only time you could do that is if that power is double that one. That's the only way you could make it, use substitution to make it look like a quadratic, a normal quadratic. What? Oh yeah, once you start talking about use substitution, grammar kind of gets really bad. Right? Because now we can figure out what U is. What do U be all about? What is U? Right? And then I'm like, somebody's going to walk by and be like, holy shit. Thank God that's math. It's not an English class. So how would I do this? Well, I do U equals, again, the same thing for the third time. U equals negative b plus or minus the square root. I mean, right? Is that cool?
Yeah.
It doesn't matter what the hell the variable is. Quadratic formula doesn't give a shit. It's just going to tell me the answer for the variable that's there. U equals negative 3 plus or minus 9 minus, I mean, we get the same shit, right? Same thing we got over here, right? Same thing. But then I go, the question is all about x, and I have an answer of u. So you better not just circle this shit, right? It's like saying, how much does Fred make? Well, Bill makes $2,000. I don't care about Bill. You know, so what's the answer for x? Well, u is this. What was that? So u, of course, was x squared. And do you see how now we just do this? So that u sub is really just a way to make the problem look better. It captures the form of what's going on. So you can use that if you like. Let me show you another problem this works for. We could actually do this problem a different way, but let me just show you what it looks like for this. What if I had this? What do you got, Jeff? Oh yeah, let's do this. What's the power on this? What's x, square root of x is x to the
First. Wait.
1/2?
square root of x. Yes, square root of x is x to the 1/2 power. Yes. Is that power half of this power then? What's the power on this guy? 1. What's half of that? Half. So yes, that power is a half of this power. So is this in the right form? Yes. If I let u equal square root of x, what's u squared? X. Looking back at you, some of you guys want to hurt me, but why would I let that happen? I'm trying to make it look more like something squared, thing, number. So that's what we're used to, right? So if I let u equal the middle dude, and u squared is related to the first dude, I can rewrite it, make it look more normal. Doesn't this become now what's x? U squared. Not u2. Still haven't found the value of frickin' x. And then, so what's square root of x?
5u.
U. Now, doesn't that look much more like what we're used to? You can actually factor this thing. I don't know if you guys see that. But if you don't want to factor it, that's fine. Yeah, let's use quadratic formula. Why not? So u equals negative b, give or take, square root, b squared, minus 4 times a times c, all over twice a. So u is 5, give or take. This will be 48, right? No, it's more than that, Jeff. This will be 96. So 25 plus 96. What's 25 plus 96? 121. What's the square root of 121? 11. So I get 5 plus 11 over 8. 5 minus 11 over 8. So I get 2 and negative 3/4. That's what u is. Let me stop there for a second. So if you're good up to here, you're good. You have to be, because the rest of this is just quadratic formula. Plugging stuff in, blah, blah, blah. You get those, right? Those are not radical answers, which tells you could have factored this, but oh well. Now, do I stop there and circle that?
No.
No, I can't. Because what's u? What do u be? U is, yeah, u is square root of x. So u is 2, or u is negative 3/4. U was square root of x. So square root of x is 2, or square root of x is negative 3/4. Do both of those give me an answer? What do I do here to get what x is? Square it. I get x is 4. That's nice. What about this guy? Can the square root be negative? No, that's not even complex. That's just shit. The square root can't be negative, so it doesn't give me an answer. The only answer is 4.
It's only 4, it's not u equals 2. Oh, no.
Huh?
Never mind.
U is 2, which leads me to x is 4, because u was the square root of x. So if the square root of something is 2, then the thing is 4. That's all it says. The other option doesn't give an answer because the square root of x can't be negative 3/4. Too bad for it. So if you like that u substitution, you can use that. It's fine. The book uses that, I think. Yes, the book uses that method. Good. Yay, book.
Can we do one that's the not U substitution?
None of them have to be u substitution. You don't
Can
have to
we
use it.
Practice on one that's not U substitution.
Well, none of them have to be. So here I could have, instead of putting u, I could have just said square root of x equals all the stuff I just did. Right? Instead of u, I could have just put square root of x equals.
Okay.
And then I would know when I get the square root of x equals 2, I would get still 4. I mean, I don't have to bring u in. U is just a way to make the problem look more like what I'm used to. It's just a middleman to make the problem easier to look at. And hopefully you guys, I went into this saying there's another way to solve this. What's the other way to solve this? Oh shit. There's a radical in the equation, so what do?
Square.
Not yet. Isolate the radical and then square both sides. Yeah. So there's a whole other way you could do this. But some of you guys might realize this is actually easier in a way. Sort of. Yeah, about the same. Okay. Yeah, why not? I'll give you guys a really nice early day. Some of you guys are like, my ride won't be here for half an hour. I'm sorry. So that's plenty for today, I think. We'll finish up chapter 11 after the 4th. Remember, now tomorrow's the 4th of July. If you want to come to school, you can. I don't think you'll be able to get on the campus. So
No, I don't.
maybe don't do that. Just enjoy the 4th.
I was saying, how can you
How can I be what?
I said, how can you be a person?
How can I be you? How can you be me? How can you be you? How can you be you?
Yeah.
A lot of practice.
I'm still kind of the U substitution. I was kind of. I didn't really like that way. So can you like help me?
But like I said, it's so if I had something like x to the 6 minus 2x cubed plus 4 0. Is that half of this?
Yeah.
Yes. So then I can just start, well, I can't factor this. So quadratic formula would go x cubed equals negative b over 2a. I don't have to use u substitution. I can just put that there.
Okay. Then you end up.
And then the last thing I have to do is take cube roots.
Okay.
Yeah. I mean, that's the other way. Besides u sub, is just to never bring the u's in. Just use the thing that's there.
Okay.
Yep.
And then you plug all of these in for the quadratic formula.
Yeah, you do the quadratic formula over here. It's going to equal x cubed. You're going to get some numbers, and then you have to take cube roots.
Okay.
Yep.
Thank you.
I was wondering if you had my test.
Yes.
Oh,
So I just
that's
start
weird. I
correction.
gave you the other thing back, but I didn't. Oh, yes, right. No, I still haven't gotten by
Okay,
there.
yeah, no,
I'm
that's
sorry.
fine. No, don't be sorry.
Yeah.
I already
No, I felt bad this morning. I was like, oh my god. All right.
Yeah, you gotta look at that SAS.
SAS. Okay, I gotta make a note.
You gotta make that note somewhere, because you're gonna forget.